Addressing syllabus statement A1.2.6, the student needs to be able to draw a diagram, an annotated diagram of the structure of DNA. We are not required to produce the helical shape. We can draw a simpler diagram than that. I'll show you a method of doing so, trying to keep it neat and tidy. So take your pencil on your examination paper and draw a gentle line like so, nice and faint line, which can act as a guide for the drawing that we're going to do on the sugar phosphate backbone on this side. I'm going to use that to draw 3 pentagons, equidistantly spaced. And of course, these represent the deoxyribose. Then extend this to form the base. These boxes need to be large enough either to have a letter to indicate what the base is or to write the name of it inside directly. Then we come around from carbon 1, carbon 2, 3, round to 4' and extend to 5' with a phosphate. Carbon 1, 2, 3, 4, 5' with a phosphate. Carbon 1, 2, 3, 4, 5' with a phosphate. Now we can connect the 5' to 3' through the phosphate to create the phosphodiester bond. So we go from here to the 3' and here to the 3'. So we have 2 phosphodiester bonds in our diagram. We will remind ourselves that this is the 5' end, this is the 3' end, and the directionality indicated with an arrow. Let's draw another set of bases, trying to keep it reasonably symmetrical, like so. And of course, what we're drawing is the complementary base pairing. Let's put some dotted lines in between to indicate the location of the hydrogen bonds. The number of hydrogen bonds does not need to be shown, as this is not required knowledge of the candidate. At this point, we're ready to turn the diagram around, which you can do with your examination script fairly easily. And then I'll just align this so that you can see what I'm about to do. So I'm going to use the bond from the base as a guide to drawing my pentagons. So let's start with the one at the top here. There's my first pentagon, second pentagon, and the third pentagon here. And then once more, we'll have to put in our 5' and phosphate. So 1, 2, 3, 4, 5' and phosphate. 1, 2, 3, 4, 5' and phosphate. 1, 2, 3, 4, 5' and phosphate. And now we put our phosphodiester bonds in. So connecting here to 3', across here like this. From the phosphate to the 3' across here like so. Once more, indicate 5' and 3' and the directionality of the polynucleotide chain. Let's turn this around. And we can begin to put our annotations in. We want to indicate that these are the sugar phosphate backbones. I wouldn't use letters. I would write this out in full. A candidate should do that. I'll use letters so that I don't confuse the diagram too much for you. Sugar phosphate backbone needs to be indicated, and we should also indicate the location here of the phosphodiester bond, which is creating the sugar phosphate backbone itself. We could then come around here and we'd indicate at the top here the complementary base pairs. So that's a reminder for us to enter the names. I'm going to use letters A to T. I'll do G to C. I'll reverse that to C to G. There's no particular ones that you should show. Then we need to perhaps take a time to indicate that this is the deoxyribose in this location here, that this is the phosphate, which is here. And of course, we should indicate that these are the bases. And of course, since I used A, T, G, and C, I need to put A, T, G, and C and add their names, adenine. And you can complete that list. And of course, the final thing that I would put in here would be to indicate the position of the hydrogen bonds as well. So I think you should write this out fully. Don't use letters like I do, unless, of course, you create a large legend which will guide you to do that. And so you end up with a reasonably symmetrical, annotated, and clear diagram, enabling you to gain as many of these marks as possible. This is one you can practice in anticipation of the examination question